Welcome to Image Processing series, where we use computation techniques into images to perform some kind of manipulation. If you are into computer vision, this series would be very helpful as you progress through more complex concepts. For the specific video, we will be focusing on one of the very basic interpolation techniques called nearest neighbor interpolation. This technique lays a foundation for understanding more advanced interpolation techniques. Interpolation is the technique of estimating parts of image while transforming it into a better version or higher resolution. The lecture is based on blog post by Kang and Atul. Do check them out. We would also be having a Python implementation of this technique later this video. Say we have a 2x2 image. Now the values inside these images are pixel intensity values. For a grayscale image, we have a single channel with 0 representing black and 255 representing white, while the remaining numbers between produces different shades of grey. In case of colored images, we split the image into 3 constituent channels of red, blue and green, and the same procedure as in grayscale will be applied, and finally the channels are combined. For the sake of simplicity, we assume the input image given is a grayscale image and not colored. Here we basically want to upscale our given input image twice its dimension. So our input image of 2x2 pixels transform into 4x4 pixels at the end of interpolation. So now we need to index each pixel in our input image. We consider the top left edge of the image to be 0, 0, and as each pixel ends, increase the axis value by 1. So the pixels are represented by the center points. In this case, the pixel of value 10 is represented as 0.5, 0.5, 20 as 1.5, 0.5. Similarly, 30 is represented as 0.5, 1.5, and finally 40 is represented as 1.5, 1.5. Now, to find the pixel values in our new image, we overlay the 4x4 image, that is our output, onto our input 2x2 image. From this, we observe that the pixel P1 is present in 0.25, 0.25, which is nearest to pixel with value 10 at 0.5, 0.5 in our input image. So we assign P1 with the value of 10. Similarly, P2 at 0.75, 0.25 is again closer to 0.5, 0.5. So we again assign it value of 10. P3 is at 1.25, 0.5, which is closer to 1.5, 0.5 than 0.5, 0.5. So we assign it the value of 20. This procedure is repeated for all pixels in the output, and we end up with our upscale image. One thing to be noted here is that this method is fast but is very ineffective, as the image produced is pixelated, as we basically duplicated the pixel around the edges. So let's implement this in Python using Pillow and view the result. The code is pretty straightforward, and for testing this, I have a sample image which we take as input. So when I run this code, we get the image as output. As expected, the output image resolution has improved, but the quality is not that great, as it is a very basic technique for interpolation. But this technique will be further used to create more advanced interpolation methods and upscaling techniques, which we will see in the later part of series. That's all with this video. See you in the next one, where we look into bilinear interpolation.